Hey guys, welcome to your Unit 4 video lesson on radicals. Today we're going to do a little review of some things you had learned in the past regarding radicals, specifically how to simplify them. All right? With that said, before we get into the actual simplifying work, we need to talk about what a radical actually does for us. Now, as many of you know, you've seen your square root symbol or your radical symbol before with different values inside that radical. All right? A couple of bits of details you need to know or vocabulary you need to know about a radical itself. When we speak of the number or a value inside the radical, that value is known as your radicand. The radical symbol you're all very familiar with, but attached to that is a root value. And in the case of the example that we see here, while it's invisible, there is a 2 there. This is known as your root value. And the reason why we're going to bring that up now is because we're going to see some examples where instead of seeing just a square root, we might see a cube root or a fourth root instead of just our simple square root that we've been dealing with in the past. And as you all know, a square root is simply used to represent irrational values in a very clean-cut way. As we know, there is no perfect square for 15, but instead of writing that decimal out infinitely, we express it as the square root of 15. Nice, clean-cut representation of what is an irrational value. So today, what we're going to discuss is how to actually simplify these types of radicals. To do so, it's a pretty easy process, and I'm sure many of you remember it from the past. First, we're going to take our radical and split it up into two smaller radical factors. When doing so and dealing with these radical factors, the left radical, we want to create all the perfect square factors that our radicand has. And you'll see why we like to keep that on the left in a little bit. Whatever remaining factors of the radicand there are going to go into our, what sometimes I'll call the leftover radical, or in this case, the right radical. From there, it's a pretty simple process. We're going to take the square root of that perfect square radical and then put our final answer together in its simplest form. However, we're going to see a couple of examples where we may be finding cube roots or fourth roots or other types of roots, but the process remains the same. Instead of finding perfect squares, we might be finding perfect cubes, and so on and so forth. But there's your process. Break down the radicand into two factored radicals, one with perfect square factors, one with everything else, and then simplify your perfect square radical. In showing you a couple of examples here, very simple and easy. The square root of 12. In this case, if we're going to break this guy down, we're going to create our two baby radicals. And again, we're looking for two numbers that multiply to our radicand of 12. But one of those numbers must be a perfect square since we're dealing with a square root. In this case, those factors are 4 and 3, with 4 being the perfect square. From there, we just take that square root, and we are done. That's all there is to it. All right? So break down your radicand, perfect squares and non-perfect squares. Take the square root of the perfect square radical, and you've finished up and simplified. To quickly show you one more, the square root of 32. This guy can be broken down, in this case, into 16 and 2. Perfect square, or the square root of 16, I should say, is 4, leaving us with a final answer of 4 rad 2. All right? Now, before we keep going, or before I let you guys get a chance to kind of cap this up for yourselves, the one thing we do want to point out is two other scenarios. What happens if we have variables underneath a radical, and what happens when we have a leading coefficient out in front of a radical? Right? Well, in terms of the variables, and we'll start there with example 3. We're going to break this guy down in an identical fashion. We're going to first start with the numerical part of our radicand. So we're going to look to break down 98 in the exact same way that we did before. In this case, That's a 49 and 2. But now, the variables. Well, what makes a variable a perfect square? It's your exponent, and specifically, an even exponent. Even exponents are considered perfect squares because we can take the square root of that even exponent. So in this instance, the c to the fourth goes entirely into the perfect square radical. And from there, we take our square root just like before. The square root of 49 is 7. The square root of c to the fourth is c squared. And our leftover radical remains the same. But what happens if you have an odd number of exponents? And what happens when you have this leading coefficient here? Well, we're going to start the process just the same. Perfect square, leftover. Start with the 72. It breaks down to 36 and 2. And now your variables. You take them one at a time. In the case of the a, that is technically a to the first. Well, since there's no even exponent there, it's going to go actually in the leftover radical. As far as the b is concerned, we see b to the fifth. Well, what we try to do is take as many evens from that as possible. Well, out of the 5, we can take 4 b's, or b to the fourth, and put it in the perfect square radical, with that 1b being left over. And now that you guys have this breakdown, it simplifies pretty cleanly. We get 6b squared, the square root of 2ab. And now the last piece, that leading coefficient. We bring it down, multiply it into our leading coefficient here, leaving us with the final answer of 3b squared, the square root of 2ab. All right? That's all there is to it, guys. So for your radical breakdowns, to backtrack one last time and to recap, we're going to branch off our radical into 2 radical factors of the radicand. The left one will be your perfect square factors. The right radical, whatever's left over. And remember, your perfect square variables are considered perfect square factors when they have even exponents. That's big to understand and remember. And from there, you take the square root of the perfect square radical, rewrite whatever remains as your final answer, and that's all there is to it. We'll discuss more with the cubes and things in class together and talk about how to break them down, but the process is very similar. Other than that, that's your lesson for tonight. We'll see you guys tomorrow in class for one last practice on simplifying radicals. Have a great night.